Welcome, everyone. Good afternoon. My name is Laura DiNardo, and I am the capstone coordinator for Arlington Tech at the Arlington Career Center. Thank you so much for joining us this afternoon for this presentation. I'm very pleased to introduce Lloyd Sayar. Mr. Sayar is the Director of Mission Assurance and Satellite Systems Transformation for Intelsat. He started his career as a satellite engineer and has now been with Intelsat for 23 years. He earned his bachelor's degree in aerospace engineering and his master's degree in space systems. And we are so excited to welcome Mr. Sayar.
Hello, good afternoon, everybody. I'm really excited to go through the presentation, going through what Intelsat does and more general what jobs are available in the satellite industry. So let's start with, we'll start with introduction on who Intelsat is, and we go through the technology, what exactly we do in Intelsat in terms of the workflow of the satellite build, launch, and operation. And we'll go through some interesting innovation that we have developed in the past few years. And we will conclude going through the different career opportunity that a company like Intelsat propose, and we'll finish with question and answers. And so please free to add any questions during the presentation, but we will address those at the end of the presentation. And I would like to answer as many questions as possible relating to how satellite work, what kind of the job that we are doing entail. Feel free to ask any questions. So let's start with who is Intelsat. So Intelsat is the largest satellite operator in terms of capacity and geographic reach. So you can see a picture on the top left corner here is actually our headquarters in Tyson's Corner. And we have different offices around the US. We actually have our control center in that building in the headquarters. And we also have a backup control center in Long Beach, California. But we also have sales office all around the world. Intelsat started launching the first commercial satellite, communication satellite back in 1965. And has been connecting the world ever since. Interesting fact is actually you've probably seen the famous picture of the moon landing, and that was actually broadcast live around the globe, and that used the first Intelsat satellite. So we have about 50 satellites currently, and we cover 99% of the Earth populated region. We actually do operate more than 50 satellites because we operate satellites for what we call third-party customer. And I'm sure you're familiar with AT&T and the DirecTV service or SiriusXM. We actually are operating the satellite for those customers at this time. So in terms of satellites, I'm sure everybody's familiar that satellites are used in a lot of different places, like for delivering television, broadcasting show, especially shows that are available live all around the globe, like for example like Olympic Games or sport events. So they're all using satellite to broadcast all around the globe, and I will go through actually the technology to be able to achieve that. In terms of satellite also used, of course, for like weather forecasting and a lot of other purpose. That this is not what Intelsat does. We purely do communication. Here actually show that, so we broadcast live events, like I said earlier, Olympic Games, World Cup. Satellite are also used to provide a phone network in certain part of the world, and also to connect community, villages in area that are hard to reach with fiber or with a network that has a LAN capability. And there's also a lot of remote schooling that have been done through satellite communication. This is really showing what Intelsat main category of communication are. In terms of mobility, we provide Wi-Fi in planes, for example. We provide networking capability in terms of the media direct-to-home television distribution. And we also have a big area where we work with the government and provide communication for the troops. So those are the four really major area of communication we are doing. There is different type of satellites, mainly low Earth orbit and geostationary satellites. Low Earth orbit are small satellites, usually a constellation of satellites. But all the satellites that Intelsat are operating are geosynchronous satellites. And the key feature with those satellites is that they are located at an altitude of about 36,000 kilometers above the surface of the Earth. And with this specific orbit, they are able to stay above the same point as the Earth rotates. So this is very important feature, so we can cover a landmass at the same time, as opposed to low Earth orbit that are really flying over the Earth's surface really fast, and that require antenna on the ground to follow the satellite trajectory. Here we can have fixed antenna, just like the antenna, the dish, for example, like AT&T service. You don't have to move the dish to follow the satellite. The satellite is always located in the same area in the sky. And that way you can also only have to use 3 satellites around the globe to cover the entire globe. You can see the picture on the top right here. For example, if you have a satellite above the Atlantic Ocean, the Pacific Ocean, and the Indian Ocean, you would be able to relay communication between, for example, US, Europe, and Asia. So that's a very neat feature of those that orbit for those satellites. So to design a satellite and to build a satellite until we actually can launch it and operate it, it takes about 3 years for getting from the design to the launch. And the satellite during that time goes through not only being built, but a lot of tests on the ground. Because we cannot afford anything to go wrong in space, because we cannot service it just like we would service a car if something goes wrong. So it is really tested for all kinds of scenarios, and there is an interesting video coming up that will actually show how the satellites are being tested. And this is one of our big satellites that was manufactured in the Boeing facility. So here, that's actually just showing the acoustic chamber, one of the tests. But like I said, there is a better video showing all of that in detail. Actually, sorry, it's coming up shortly. So the design of the satellite, it's on the left here, you can see this is what we call a three-axis stabilized satellite, and with the solar array on the north and the south. This is showing a cruciform shape, a solar array. You can see that there is 4 reflectors for communication. The satellite is pointed at the Earth, stay within 0.05 degree accuracy, so it's very, very precise. To give an idea, the size of the satellite is, with the solar array, it's half a football field, so it's very big. And in the video, you're gonna see the deployment in the factory of the solar array. It's very long. At launch, it's about 6.5 tons, and half of it is actually propellant. Yeah, and most of the test is also to make sure that the satellite can really resist the environment in space, which goes from very hot to very cold, with the sun rotating around the satellite each day, and also the space weather and particle bombardment. So we currently have 52 satellites, and we really have satellites from every major commercial manufacturer, with 14 from Boeing in manufacture in Los Angeles. Maxar used to be called Space System Loral, recently changed the name to Maxar. We fly 25 satellites. They are manufacturing the satellite in Palo Alto, California. Northrop Grumman, that changed also the name, used to be Orbital Science. Now they are Northrop Grumman. We fly 11 satellites. They are located nearby, next to Dulles Airport. And then we have the two manufacturers from Europe, manufacturer in France. Thales is in Cannes. We fly one satellite, and Airbus in Toulouse, one satellite. And those are the Intelsat satellites. As I mentioned earlier, we fly actually more satellites that are not showing here for third-party customers. Intelsat is growing fast. We currently have 10 satellites that we order with 3 different manufacturers, 6 with Maxar, 2 with Northrop Grumman, and 2 with Airbus. So we really have a busy 3-4 years ahead of us. We never had 10 satellites in order in the history of Intelsat, so we are definitely growing fast and have a lot of work coming in the pipeline. So let's go through the video about the testing on satellites. Okay, so before I talk about this slide, I just want to point out some interesting things with this video. One, you could see the satellite was being shaked. This is really to test the resistance to the G's because the satellite will be in the rocket, and this is really the phase that is the most critical in the satellite. It needs to resist a lot of vibration in the rocket, so that's being tested in the factory. Another interesting test here we couldn't see on the video is the deployment of the reflector and the deployment of the solar array. You could see there was some wire, and at the top of the wire there is actually the balloons in the facility, because that's to simulate the 0G, because in space there's no gravity, right? So the solar array actually, if they would just try to deploy it like that, it would probably break because of it's so long and it's material that is very lightweight. So it's actually supported with balloons that replicate 0G. And lastly, there was actually the thermal vacuum chamber. That's probably the most critical test the satellite is put in a chamber where the pressure is taken out to simulate again 0G in that chamber. And then the satellite goes through a different cycle of temperature, going through very cold temperature and very hot temperature to simulate the environment of space. And all the equipment on the satellite is being tested in those conditions. So after the satellite is been completely tested, it goes to the launch pad. Here we are typically using on the left, you can see that's Ariane 5 launch from Kourou. In the middle, this is SpaceX. So recently we started using SpaceX for launching satellites, and I think this is probably in the future we will be using more and more SpaceX because they are really commercial, very efficient in terms of cost, since they are reusing the rocket, since they are landing the rocket after launching it. On the right, it's the Proton launch from Kazakhstan that we also have used in the past. So here, after its launch, there is what we call the transfer orbit and deployment phase. So the satellite, once it is separating from the rocket, it is actually what we call in the rotisserie mode. You can see that it's spinning. This is to provide not only stability, but also to provide power. You can see the solar arrays that are folded. There is minimum power provided by those solar arrays on the side of the satellite here. And so the satellite first has to be moved to the correct longitude and altitude. And we use the engine you can see on the back of the satellite. And typically we do 4 big maneuvers to reach the proper altitude. Once it's at the proper altitude, you can see that we are doing the deployment. So here we are deploying the reflectors, and then we'll be deploying the solar array. And this, of course, is all done from the ground. We have a control center where we send command to the satellite to activate all those phases. Here we can see the deployment of the solar array. And you can see that there is also some reflector at the top of the satellite. Those are smaller. They are like what we call like spot antenna. So I will mention what they are for. We have different type of communication services. So sometimes we use bigger reflector for and sometimes spot antenna. And here, lastly, you can see there is the deployment of the arm with the those are actually thruster at the tippy top of those arms, and those are electric propulsion actually, and they provide a lot more efficiency and using a lot less propellant. And here, that's how the satellite looks at the end. It's with the solar array pointed north and south, and the satellite always looking at the same point at the Earth, in the equatorial plane. So let's talk a little bit about innovation. So the communication is changing rapidly. You know, like 20 years ago, or even when Intelsat started in the 60s, a satellite was launched to carry a few channels of phone lines, for example, or a couple of channels of TV service. And now you can see it's more a network of interconnectivity from Wi-Fi in the plane to connected cars that are coming soon, to corporate company that have multiple locations around the world that need to set up network to communicate among themselves, to boats that are in the middle of the ocean that need Wi-Fi now to entertain the crew. So the industry is really changing rapidly, And what we are seeing is more a network of different technology that are getting blended together with LEO constellation that are coming up soon, and GEO satellites that we are operating. And in terms of communication innovation, Intelsat is on the forefront of developing very large satellite with new technology in terms of beamforming, where in the past those reflectors, for example, would cover the entire United States, for example, but then you wouldn't get the bandwidth that is very high in a specific area. Now we would be able to have beamforming and say, let's have more bandwidth on New York, for example, and Los Angeles, and less in the countryside, because we don't need that much bandwidth there. So we are able actually to change dynamically the communication based on the need. Before, we had to design the satellite and then we could not change it. If we wanted a new service, we would have to launch a new satellite. Now what we are doing is launching a satellite that has capability by software on the ground to change the technology on the satellite. We actually call it software-defined satellite, and those are actually the two satellites we ordered just a few months ago from Airbus. Another innovation in Intelsat, we are actually the first commercial company doing a docking with another commercial company. Originally, of course, we know NASA with the space station are doing, docking, but no other corporation, private corporation, have done that in the past. And last year, around this time in February, we did that for the first time. So we had a satellite that was getting at end of life, Intelsat 901. Why it was getting end of life? It's because it was running out of propellant. But in terms of communication, the technology on the satellite was still working, functioning perfectly. So what we wanted is to extend the life of that satellite. So we contracted with Northrop Grumman, and they designed a satellite that has the capability of attaching to the back of our satellite on the apogee motor, the thruster that is on the back of the satellite, and that satellite then can provide the maneuvering for our satellite IS-901. And we still are using the communication. So it's been 1 year now that those two satellites are docked together and operating successfully. And we are actually in the process of doing it with a second satellite, Intelsat 1002. And if you look at the Intelsat news in the coming couple of weeks, you will definitely see that because we are in the middle of working on that. Well, as I said, the main benefit of the MEV is really to extend life of the satellite and to provide more flexibility. We could move the satellite in a different position around the Earth, and we also can cope with procurement delays or launch failure. So here I have another video of the mission with the Intelsat 901 and MEV-1. Okay, so that was an exciting video about that mission that we did, and we are about, like I said, to do another one in the coming days. So let's talk actually about career now. I think a topic that is very important for you. So Intelsat, there's really the obvious is the engineering kind of jobs, and I think that's probably what you are more interested. But I just want to note that a company like Intelsat has all the supporting jobs that you would find in a normal company, like the financial and corporate planning, forecasting, sales, lobbying, regulatory, human resource, corporate communication. But in terms of technology job, there's a lot of different fields, and in terms of what we call driving or operating satellite, this is really the field that the department that I am in. There's building satellites. This is really the manufacturer that builds the satellite. We don't build satellite. We work on design. We provide requirements, and then the manufacturer builds satellite based on our design. So we have a department in Intelsat that work on requirement. Then a building launch vehicle. Again, we don't do that. This is the SpaceX and the Ariane, but we do procure the launch with them, and we monitor the project management to make sure that they're on time delivering the rocket, so the satellite will be launched on time. Testing modem, transponder, RF equipment. So we have a lot of technicians that work on that end. Calculating link budget. Since we are a communication company, we have a lot of groups that deal with providing, working with the customer and deciding what, based on the capability of our satellite and the demand of the customer, work on the link budget and allocate the proper bandwidth for the customers. We, of course, work on new product development. Teleport operation, we have a lot of teleport around the globe. Those are actually places where they have antenna that are like 10-meter diameter, like huge antenna to relay between the satellite, and those teleport also provide the connectivity for the satellite in terms of for the operation team. We get telemetry from the satellite. We send command to the satellite, so we use the teleport for that. We have fleet management, planning. So software engineering, because all of that job being done, performing, calculating link budget or operating satellite, we are using custom software to do that. To send command to the satellite, to analyze the telemetry coming down. We have a department that does the software. So my group in operation provide requirements to that department that then develop the software, test the software, deliver the software, and then the operator, the user, the engineers are actually using those pieces of software. So software is always very important. Then we have project manager, of course, to manage all kind of projects, and we have quality control. So in terms of all those jobs, it's possible to get degrees in a lot of different fields. In terms of the operation and engineering department in Intelsat, we tend to look for people with engineering background, primarily aerospace or electrical engineering. A strong background in coding is very important, and Python is really the common tool used now, common language. For example, our engineers are writing procedures in Python, and those procedures are used to send command to the satellite. So even if you're not a software engineer, you still need the Python knowledge to be able to write code as a satellite engineer. And I would say MATLAB is very used for doing analysis and deep into the math and the physics. So that's pretty much it. I think I want to make sure I can answer as many questions as possible. So I'm going to turn into the questions. So the first question is in terms of cost. So we are dealing with very big satellites, but then again, there is very large, and the cost can change. But I would give a ballpark of a typical geostationary satellite costs about $100 million. Then it's about the same, $100 million to launch the satellite. And typically we want to insure the satellite. And the insurance can be also very expensive, in the order of 50 to 100 million. I would say one satellite will cost the company $250 to $300 million to design, launch, and then start operating. In terms of, there's a question about the low and high temperature in the thermal chamber. I don't recall the exact number, and I don't want to quote, but it's not as extreme as what you would think. So it's not like we're going to be cooking the spacecraft or going super low. It's in the order of the -20 to +50 C. Sorry, that's Fahrenheit. What is the favorite thing about the job? And that's a very interesting question. I add a slide showing all the manufacturers that we have, we operate in satellite. So, in this field, you can decide to go work for the manufacturer, like, Boeing or Northrop Grumman. And it's very cool to design satellites to work at the manufacturer. But you don't really, you're going to be working with one type of satellite. At Intelsat, we really have a chance to look at all the different designs from all the major manufacturers. And it is very interesting to see how different manufacturers are solving problems, and to be exposed at all that technology from every manufacturer. So I think I really enjoy that part. Now, what is very exciting is, we always want everything to go right with the satellite. We want them to be healthy. We want them to not have any anomalies. Unfortunately, things happen with hardware. There is failure. Satellites are designed to cope with failure. They are designed with, it's like designing a car with 2 batteries, 2 alternators, 2 engines, and because we cannot go change anything. So even if it's designed with redundancy in mind, with failure in mind, there's still some anomalies that are really unexpected. And I think this is really, as an engineer, what is really exciting, because then you need to solve problems that nobody thought about. And I mean, I could give tons of examples of, you know, getting called in the middle of the night because we get tons of alarms in the control center. And I always give the analogy of a satellite engineer is like a doctor, because you have to diagnose, you have to look at the data, and you have to take action, but you cannot really look and touch the patient. You're looking at data on the screen, you're getting telemetry that from 36,000 kilometers away, and you have to analyze that, you have to plot that, and from what you see, you have to understand what is happening, and then come up with an answer and to send command to the satellite to fix something. And that's probably the most exciting. Like I said, we don't like anomalies, but honestly, that's the most exciting time in this job. In terms of qualification and job training, like I said, a bachelor degree in an engineering field is enough to get a job in Intelsat. We have training, and I mean, it's not like when you start on Intelsat, you can start sending commands to the satellite. We actually have simulators for all the satellites, so we have a lab environment, and we are testing everything on the simulator. A little bit like a aircraft pilot who actually learn how to fly before we give him an aircraft in his hand. So I would say engineering degree with some, you know, internship to get some hands-on experience is a good start to start in a place like Intelsat. Any advice? So things have changed a bit since I was in college and I started in Intelsat, but I can give advice on what we are looking for in terms of college applicants. Like I said, Python knowledge. Even if you want to be aerospace engineer, not a software engineer, make sure you spend time learning Python and be familiar with Python, because you're going to use that quite a bit. Be familiar with MATLAB. This is very important as well. And I would say a lot of engineers think about focusing on the technology side. Think about the communication part and the social part. It is, I mean, too often engineers are very good with math and physics and not too good with communication skills. So make sure you get chance in college to work in teams and engage and try to lead a team. I think during interview it's very important to understand if the applicants are, you know, just working on a team and doing their work, or actually actively engaged, communicating, you know, managing the team. I think that's what we are looking at in applicants. Who inspired me to do that? I mean, everybody is different. For me, I think I was 15 and I knew I wanted to do that. I did aerospace, and I knew after aerospace I would drop the aero because I didn't really want to work with aircraft. I wanted to do only space, so I did a master in space systems. So for me, I had a clear definition of what path I was going into. Like I said, everybody is different. What does the launch market look like in the next few years? So this is interesting, and like I say, I think SpaceX is really changing the launcher industry quite a bit. Ariane was very the primary launcher for commercial satellites, because of course military satellites in the U.S. have been launched by the you know, the Delta, the Titan, and the U.S. launcher, and those are prohibited in terms of cost for a company like Intelsat to launch. They are way too expensive. So we are going with Proton Ariane, and SpaceX is really changing everything with what they are doing because they are really bringing the cost down. So that they are definitely, like I said, we're going to be using SpaceX quite a bit in the coming years. So what class would I recommend to take in high school? So in high school, that's interesting because I spent some time talking about college, but high school, I would say, focus on the math and the physics, and start gaining some knowledge in terms of language like Python. But again, it's math and physics focus. If satellite engineering is what interests you. I mean, you probably can tell from my accent, I'm not from US, I'm from France. So I actually have a baccalaureate in high school. I know in US, the equivalent is that international baccalaureate. And definitely the math and the physics was a focus. I had like a high school degree in math and physics myself. What is the lifespan of the MEV and the latency to the rendezvous at GEO? So the MEV took about 3 months between the launch and the rendezvous. And one thing that I didn't talk about is the fact that I talk about a lot of tests being done in the factory, but then we do a lot of tests once the satellite actually is deployed and in the right longitude, because the satellite could have suffered a failure during the launch. So we retest everything. Number one, all the what we call the bus equipment, so everything, attitude control system, power system, thermal system, propulsion system. Once that's all clear, then we focus on the communication side, and that, so the bus testing is about 1 week, and then the communication system testing could be up to a month to test all the connectivity. In terms of the MEV, they also perform the test, and then the rendezvous takes also another week to navigate, to be close to the satellite before docking. What types of engineers that are not as obvious work for Intelsat? So of course there's software engineering. Like I said, we have a team that develop software. We have a communication engineer that focus more on the communication side or on the RF side. Mechanical engineering. Mechanical engineering is actually very close to aerospace engineering. I mean, the first 2 years in college, you actually do the same classes in terms of math and physics. It's only the last 2 that you start doing more aerospace. Beside that, less obvious, I know that there is new fields. I mean, there is like industrial engineering now that was not around when I was in college. And this is actually an area that I'm focused on since I lead mission assurance. So everything related to quality assurance, quality control is very important in an industry like the satellite industry, because we cannot really have failures. So everything is, like I said, the testing during the building of the satellite or anything before we send any command to the satellite, we test everything on the simulator. So we have really processes that are really specific, and we need quality control to develop all those processes. So I think we reached 2 sharp, and there's no more questions to answer. So
we actually have 2 questions that were submitted ahead of time. One of them is, what would be the roles of companies versus the role of public funded space programs in the future?
That's an interesting question. I think it's in the past, if we go a long time in the past, it was mostly funded by the government. And I didn't go through that, but the history of Intelsat actually was funded not mainly by US, but by a lot of countries in the world. So it started as a intergovernmental organization, and then we did a privatization back in 2001. So there's a shift from being more governmental to being more commercial. And I just gave the example with Intelsat, but you can see it with SpaceX doing what really NASA was doing in the past. There's really almost no path forward for NASA to develop like the next space shuttle, for example, or I mean, SpaceX might be the first company going on Mars, beating NASA. So I think there's a shift from governmental institution leading the space industry to commercial entity leading the space industry. And again, that's my personal opinion, but that's what I think the history has shown. Okay, what is the second question?
The second question, and I believe you may have answered this, but to honor the student that submitted this question, is what are some types of engineers that may work for NASA? They may not be as obvious as an aerospace engineer. And I guess it could be that work at Intelsat too. Mm-hmm.
Yeah, so I think I answered that already. So there's, but again, in every company out there, and including NASA, they have all the supporting roles, right? So on the slide that I show, that was actually right here. All the non-engineering stuff is going to be present even in NASA, right? They do corporate communication, they do budgeting, forecasting, and all those things, and they do project management. So there's going to be all those jobs available as well. I would say the jobs for the difference between a company, for example, like Intelsat and NASA, is NASA probably you will want to continue education even further than graduate school, maybe with a PhD, to be more like a scientist in a specific area, like in the propulsion subsystem or in the thermal subsystem. So you need a deeper understanding with a PhD. As of for a company, like Intelsat or even like the Boeing, Maxar, or Northrop Grumman, I think a solid engineering degree, solid background from a good college, like we have in Virginia, like UVA or Virginia Tech, will give you that base to get a job. So I don't know if there is any more questions, but we run out of time as well.
We do not have any more questions in the chat.
Okay, well, let me look at the chat to see if there's anything else. No, I don't see anything. So, well, I mean, I thank you, everybody, for the opportunity and to share all that information with the students. I was really, I mean, it's a field that I'm really excited about. The fact that I'm 23 years in it probably proved that. And again, Intelsat is a very exciting company. And we have a lot of satellites that we procure from different manufacturers, and the future is definitely bright with all those projects that we have in the pipeline.
Thank you so much, everyone, for joining us today. The recording will be available. And if you have any questions, you can send them to your teacher and we can forward them to Mr. Lloyd. Thank you so much.
Thank you.